There are cables and a controller, and then a set of power supply. Before we plug in power, we need to connect the cable first. The cable has a foolproof mechanism. After connecting it, the power supply also needs to be connected. Then connect the power. Then the part of AC is also. Connect the power. After the power light comes on, turn on the power switch right away. Wait for the controller to start up. Okay, after the controller booting is complete, there is a start button here. You can click it. Okay, that's how to turn on tools. As to the screwdriver, there are 3 buttons that can be pressed. Here, button A, button B, and the trigger button. The A and B buttons can change the spinning direction of the screwdriver. The green light indicates the counterclockwise mode. If you press the trigger button, the screwdriver bit will spin counterclockwise. Button A can be used to set up clockwise tightening mode. Under this mode, we can start the screws tightening job. Then we can tighten screws securely according to preset up parameters. That's all about using the screwdriver. There is a View Screws section on our main page, where we can check results from the latest tightening process. In addition to that, on the main page, we can also check the presetting values of target torque and final torque, along with the angle value of the locking process. The second page shows the waveform of torque values detected, while the third page displays results from each section of the locking process. The monitor section shows relevant numerical data for this set of parameters, such as torque values with upper and lower limits, set at 0.8 and 0.6 respectively, angle value with an upper limit of 3600 degrees and a lower limit of 100 degrees. Clicking on the gear icon, we can set up related operation data of the controller. Inside Login section, if logging with the administrator role, you can set up and change controller global settings. If login with the supervisor role, for the global settings of the controller, we cannot set up the data of Wi-Fi or TCP IP. Only parameter or job related settings may be changed. That default administrators. Password is 1111. After login, you can see that there are a total of 5 clickable setup pages. As information, we can see that the relevant serial number of the controller and its firmware number. And there is the part of the screwdriver. We can also check the information about it. The setting page is mainly about this. Controller, related to the global parameters of the controller that can be set. Here are the setting of the language or unit used, or whether to turn on the buzzer or not, etc. These parameters all can be set up here. As program page, we can set up parameters stored inside the controller. Inside, we can see that we can set up parameters or jobs. After the setting is complete, we have to enable. You can enable operation mode on this enable page. Data log page. If the client has USB flash drive or other USB storage device, we can enable this option to this page. After each tightening is completed, tightening results will be stored inside the USB storage device. As the correction section, we can do the data correction related to the screwdriver, then click Sign Out to return to the home page. In the parameter settings section, log in first. Click Setup on the program page. Take setting parameter 1 as an example. First, under the page of parameter 1, you can set up the name of parameter 1. For example, if the screw we want to tighten is M3 screw, then you can select basic or advanced mode. Use basic mode to set up. The first line is target torque. We can set up the torque value we want. Taking this as an example, we want 0.7 Newton meters. Then we can enter to different speed data here. We can set the speed of the first stage to be faster. That stage is before the screw starts to get tightened, using a faster speed to do the tightening. Then before the screw is about to be tightened, slow down the speed. The angle is our deceleration angle. Take this as an example. We set the angle at 800. This number will depend on the length of the screw. What about the speed number? This is the number of revolutions for the second stage. The lower, the better. Lower speed will make the precision of our tightening higher. Let's set it to 70. Then this section can be fine-tuned. Fine-tuning for different types of screws and conditions. As the second page, mainly focus on the result judgment after the screw tightened. Criteria for judging OK or N. Here we can set up two numbers to monitor. We can set upper and lower limits for the value of the torque. Taking this as an example, we set an upper limit of 0.8 Newton meters, and the lower limit is 0.6. In the same way, the angle value also has upper and lower limits. After the tightening is completed, we can see the result. See if this number falls within this range. Here, the upper limit here is 3600 degrees. The lower limit is 100 degrees. Click less than save button. The data will be stored in parameter 1. Then we have to enable this parameter. In this case, we just set parameter 1. We can enable parameter 1 here. After the enabled action, the parameter data will be uploaded to the screwdriver. If we operate the screwdriver, it'll operate the way we set it to. Tighten the screw. After tightening, on the monitor page, we can see the final tightening torque value. Also the final angle value. On the second page, we can see the waveform of torque values. On the third page, there are the results of each stage of tightening. If on, what caused then that the torque value is too high? Cause the end result. Here we set the upper limit at 0.8 Newton meter, but the final tightening torque value exceeds the maximum torque value. Then the system will show an error. Like this, I had the screw tightened. If we tighten the screw again, even though the torque value falls within the range, the torque reading is within the range, but the angle reading is out of range, the screen will also show on. After connecting to the computer via USB, we can execute the UI app on the computer. To connect with the controller, click here. Select the right COM port to do the connection. After connection, a prompt will ask if you want to get the parameter data from the controller to the PC. Here click Yes button. The UI app will retrieve the relevant parameter data from the controller. As screen shows, there are 5 separate pages in total. The monitor page is mainly for the display of tightening results. There is a waveform display, and whether the torque data setting is okay. All these data are on the parameters page. This page shows the current parameter data stored on the controller. You can edit and modify the data values here, then store it back to the controller. The system page mainly displays information about the current controller and screwdriver, like firmware version number or serial number, etc. Here, we can see the waveform displayed after tightening. The yellow curve is the data for the angle. The blue curve shows the data of torque values. At the same time, we can check data log page about the information of the latest tightening work. For like the final torque value, and the final angle, and the final result. There will be 3 files stored separately. In the result file, it will show the same as in data log. The data includes the setting value of the target torque, and the setting value of the target angle. Also, the final torque and final angle values of tightening. In the second file, we can also see the raw data of the waveform. Related data will be stored in file every 10 milliseconds. In the same way, the data of the angle will be stored in the file.